So the next lecture is on the sources of failure or failure of generation. So let's start. So as you know that every equipment or part have some life cycle from the design stage to the maintenance stage. So failures may be generated at various stages of equipment in these life cycles. So they are classified in simply as first from design stage to improper selection of materials, then to presence of defects in raw materials, then the errors in the manufacturing stage, then the failures in the improper heat treatment process, then maybe due to the assembly, erection and installation stage failures, then in the misuse or abuse of a product. So next is the operation stage failures, and the last is the maintenance stage failures. Okay, so let's go deep in each stages. So first one is the design stage. So a poor design can cause failure of engineering components. So the presence of stress concentration factors like sharp fillets, notches, keyways, etc. may result in the failure of the component. So also the sharp changes in the cross section may also results in failure of a particular component. So care should be taken while we design a particular component. So improper knowledge in the design may result in the failure. Also the inability to use proper design guidelines. As you know that for different components or different for applications there are a lot of design guidelines. So care should be taken, or you must follow these design guidelines, otherwise there may be some failure occurrence. So next one is second one is the improper selection of materials. So the selection of material that is incapable of providing adequate mechanical properties such as strength, fatigue resistance, toughness, corrosion resistance, etc. for the application may lead to failure. As you know that for different applications, different type of properties we are using. For example, if you are taking a component which is in the vicinity of some water, so that material should be corrosion resistive. So otherwise corrosion will occur and it affects the total component. Okay, likewise care should be taken while selecting the materials. Also the anatropy of material should also be considered while selecting the material. So as you know, isotropy means at any direction in one point of a material the properties must be same. So in one point in different directions the property must be same. So these anisotropy means it just opposes the isotropy. Okay, so that may result in the total strength of the structure. Okay, so next is the presence of defects in raw materials. So on choosing the raw materials used for manufacturing and engineering component may contain defects that was generated during the manufacturing process of raw materials. Okay, so for example the rods, plates, etc. produced by bulk deformation process like rolling and forging, etc. may have unfavorable grain flow and surface cracks. So these cracks may result in the total failure of the system. Also the castings may have blowholes, porosity and dissolved gases that may result in the total failure. Also use of such defective raw materials will offer poor mechanical properties. So the total life cycle of the component may shorten due to the defects in the raw materials. Okay. So next is the manufacturing stage. Next is the manufacturing stage failures. So a wide range of manufacturing processes are used for obtaining the desired size, shape and properties in the stock material. So these properties includes welding, these process includes welding, forming, machining, etc., which has to be selected properly, which otherwise can lead to defects, metallurgical changes, etc. So for different applications we are choosing different type of process. Okay. Next is the improper heat treatment. Failures resulting due to the improper heat treatment. So metals such as iron, magnesium, copper, etc. is generally heat treated to obtain the desired properties as per the needs of the end application of the component. So as you know that for different applications we are treating in different manner. We are heat treating in different manner. Okay. So in the inappropriate selection of parameters such as the heating rate, peak temperature, soaking time, cooling rate, etc. can result in unfavorable metallurgical changes and the mechanical properties that can eventually lead to failure. So all the structural properties are basically depending on the metallurgical properties. So if the metallurgical properties or the metallurgical characters changes, it may result in the total failure of the component. For example, the overheating of hardened steel components for long can cause oxidation, excessive grain growth, cracks, etc. So this may result in the failure. So next is the assembly, erection and installation stage failures. So errors in the assembly can due to the incorrect procedures, misalignment, proper workmanship, etc. and it may result in the reducing the total life cycle of the component. So next we are moving to misuse or abuse of a component. So the incorrect use of a component may lead to failure, as you know it. So the manufacturer of a component may provide a service catalog which contains handling procedures of each part of the equipment. So the total working must be following the service catalog. Okay. For example, the loading and unloading of a workpiece in a CNC machine has a certain procedure. Ignoring this may lead to the failure of the system, as you can see in our CNC machine. Okay. So next is the operation stage failures. The failure can occur due to the abnormal service condition experienced by the component for which they are not designed. Okay. So each component or each part is made for each ambient condition. So care should be taken while selecting this. So it can be exposure of a component to high rate of loading, corrosive equipment, high or low temperature, etc. Okay, as you know it. So last one is the maintenance stage failures. Failure can happen due to the poor maintenance strategies also. So almost all the equipments need proper maintenance at a proper duration of time for their lasting their life cycle. Okay. So well-planned maintenance activities help to minimize the failures, like what, when, where, who, how, etc. should be taken while the